Our objective today is to use various methods to solve rational and quadratic equations. Particularly for quadratic equations, we have several ways we can solve them. So we typically have one way to solve the rational, otherwise called fractional equations, and that is when we're going to multiply every term by the LCD, because the goal is to clear out the denominators. And we're able to do this with equations. And once we clear out the denominators, we solve our equation just like a standard, typically a first or second degree equation. So I'm just going to walk through some examples to show you what I mean, and this should be review for most of you, I think. The first one, y over 2 minus 2 is equal to y over 3. We want to find our LCD. And it's the product of every different factor you see. I can put the 2 over 1. So I have a 2 and a 3. The LCD is going to be 6. We're going to use that to clear out the denominators. So 6 over 1, let me change the color here, times y over 2 minus 6 over 1 times 2 over 1, and that's equal to 6 over 1 times y over 3. And this is usually a process that the pre-calc students don't have any, you don't have any trouble with this. You have trouble when you don't have an equation and you start to confuse the different processes. But here, since it's an equation, as long as you do the same thing on both sides, we are good. So then we can reduce. That's a 3. That doesn't reduce. That's a 2. And our new, simpler equation is 3y minus 12 is equal to 2y. So y is going to be 12. You can always check your work by substituting back in. If I just did that mentally, I would have 6 minus 2 is equal to 4, and that is correct. So now we're going to get slightly more complicated. We have a couple of binomials here, and please notice that I put parentheses around my binomials, even though they're not shown like that in the book. It's always a good thing to do. We still need an LCD. And when I look at this, I'm actually going to factor a 3 out of this. So the first thing we want to do is to factor anything we can. And I'm just going to cheat a little bit and put it right underneath. Okay. So now when I look at that, I got to choose one of every different factor I see. I have a 2, a 3, and an x plus 1. So my LCD is going to be 2 times 3 times x plus 1. So 6 times x plus 1. That is sufficient to clear out the denominators because you have one of every factor, so you can reduce them down. So here we go with that. We want 6 times x plus 1 over 1 multiplied by the 3 over x plus 1 minus 6 times x plus 1 over 1 multiplied by the 1 over 2, and that's equal to 6 times x plus 1 over 1 times 1 over, and I'm going to write my factored form because it's much easier to reduce when you have your it's all factored out. So now I start reducing. Boom, boom. That's a 2, that's a 3, the 3 and the 6, a 1 and a 2, and a 1 and a 1. And then we clean it up. So we have to be careful with the cleanup here because it gets a little cluttery. 6 times the 3, that's 18, minus what I have left here is a 3, and then in parentheses an x plus 1. And on the other side, the only thing that's left is 2. So now I have a first degree equation, just like we did way back in algebra, 3x minus 3. Don't forget when you distribute, when you have subtraction, if you still do the plus minus, you can do the plus minus. That's totally okay. I don't do that, and I don't think your college professors will do that, but you can keep doing that. That's fine. Okay, so we start reducing things down, and I have negative 3x is equal to 5 minus 18, so that's what, like negative 13? Divide by negative 3, and I have x is 13 over 3. Nice thing about pre-calculus is we don't need to have pretty whole number answers. It can be anything. So 13 over 3. Okay. Okay, and then we step it up to where we have different binomials in the denominator. I'm going to factor this guy, and he factors into x plus 1, x minus 1. That happens to be our LCD, x plus 1, x minus 1, because you have one of every different thing you see. So we go through and clear out. So I have x plus 1, x minus 1 over 1. Hopefully I don't run out of space here. Times 4 over x minus 1 plus the same thing, x plus 1, x minus 1 over 1 times 2 over x plus 1, and that's equal to x plus 1, x minus 1 over 1 times 35, x plus 1, x minus 1. Then we start reducing. Boom, 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 boom. And it cleans it all up. So let's see what I have. I have 4 times x plus 1 plus 2 times x minus 1, and that is equal to 35, if I didn't make a mistake. Distribute 4x plus 4 plus 2x minus 2 is equal to 35. 6x plus 2, 35, 33. X ends up being 11 halves, which is 5 1/2. Okay, so here I want to show you how you can just remind you how you can check your work by using your graphing calculator. And I haven't really talked about Desmos yet in this class, but if you go to desmos.com, I know you did the little activities the other day, but it's a really nice user-friendly calculator, graphing calculator to check your work. So you just enter things in directly. If I show you, if it'll let me show you, it won't let me show you, I guess. You can enter things directly in here. See what I did? I took my equation and I subtracted the other side. So essentially this is set equal to 0. And you can come over here and you can find your solution. The solution is 5.5, just like we had it. So again, Desmos is a really nice user-friendly graphing calculator to check your work. Okay, so the second half of this lesson is solving quadratic equations. You guys have been solving quadratics since, I don't know, 8th grade probably. There are several ways to do that. I'm going to show you just a few of them, or remind you of a few of them. The first way is to factor, which, I don't know, lately all the pre-calc kids hate factoring. I don't know why, but y'all do. You can complete the square. Once you understand how to complete the square, I find that a lot easier than our next option, which is using the quadratic formula. I really don't like the quadratic formula. Well, I mean, it's okay, but using the quadratic formula, there's just a lot of places where you can make a simplification error, and it just, there's a lot of room for error with that. And then, of course, you can always solve it graphically. And again, try out Desmos. It's really easy. You just type in the left-hand side, and you can graph it, and it looks nice. A lot nicer than the TI-84s. Okay, so I'm going to go through those 3 methods very quickly. Here we have one, 4x squared minus 4x minus 15. It could be a bit complicated to factor. I know you guys you learned a different way last year with Mrs. May, where you separate the middle guy. Totally, that's great. Go ahead and use it. I don't use it enough to teach it in here because I would mess it up, and that would not be good for anybody. So I'm going to go old school, and I'm just going to factor this thing because I know it factors. And when you have something like this, I know 15, I'm guessing 15 is going to break up into a 3 and a 5 because my center number isn't very big, so 3 and 5 are probably what it's going to be. I'm going to guess that this is going to be 2x and 2x because more often than not it is. When I look at this, I need a difference of 4 between the two. So here I have a 6, here I have a 10, so this is going to work. I got a -4, so my 10 has to be negative. My 3 has to be positive, and then I'm good. When you're factoring, just as a reminder, we set each factor equal to 0. Because for the right-hand side to be 0, one or the other has to be 0. That's I think it's the zero product rule is probably what that's called. I don't know. So x is negative 3/2. 2x is equal to 5. X is 5/2. So I have two solutions, negative 3/2 and 5/2. Or you can write them as negative 1.5 and 2.5. Okay, my second example, if you look, I have no factors of 1 that would add to a negative 6. So this is not factorable, but it looks like an easy target or an easy option for completing the square, because this guy is even. I only have 1 as the first coefficient, so it's not too bad. So here's a quick example of completing the square. I need to create a perfect square trinomial on the left-hand side, and I need to toss any constant term to the other side. Now, I usually put a blank in here, and this is negative 1 plus whatever I'm going to add. Okay, I got to add a number in here. Whatever I add here, I got to add to the other side to stay balanced. And I basically want to make a perfect square trinomial. So I take the center number, I ignore the sign, center number, divide it in half and square it. So 6 divided by 2 is 3, 3 squared is 9. That's what I'm putting in the blanks, 9, 9. Now this guy factors into the square root of the first term, the sign of the center, the square root of the second term twice. And this is 8. I'm going to take the square root of both sides. Since I'm taking an even root, you need to add plus or minus because you have two possible answers. Square root of 8. And I have x is equal to 3 plus or minus 2 radical 2. So that was a really easy one to do with completing the square. Finally, I'm going to torture myself with the quadratic formula for this one. Remember the quadratic formula, and this is a formula you might remember the rest of your life because I know I have. Negative 1 times b plus or minus the square root of b squared minus 4ac all over 2a. A is 2, b is 1, c is 3. So here we go. X is equal to negative 1 plus or minus the square root of 1 squared is 1 minus 4 times 2 times 3 all over 2 times 2. So it's negative 1 plus or minus the square root of 1 minus, oh, what's that, 24. So that's negative 23 over 4. So we're going to pull that imaginary number out of there, and it's going to be negative 1 plus or minus I radical 23 over 4. So typically you'll see the I in front of the radical so you don't confuse it as being inside the radical, but it's fine if you put it on the other side as well. So that is a quick review of solving rational equations and quadratic equations.